Ah, Fundamental theorem of arithmetic. This is a topic in class 10 real numbers chapter. Okay. So what this theorem states, so this is this. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So what does it mean? First we will see composite number. Composite number means it has more than two factors that can divide the number completely. I will take for example 4. See, 4 can be divided by 1 completely, correct? And 4 can be divided by 4 completely, correct? And this 4 can be divided by 2 also completely. See, there are how many factors can divide 4 completely? 3. 1, 2, 3. 3 means more than 2, right? 3 is greater than 2, correct? So 3 factors means greater than 2 means more than 2. So any number, I mean this number, any number that can be that is having more than 2 factors is called as composite number. Got it? Now this 4 is the composite number. Okay? That you this you understood. Next. And this they are telling this composite number can be expressed or we can say factorized also as a product of primes. Primes means I will tell. For example, so now 2 is a prime number. Okay, 2 is a prime number. So prime number means it has only two factors that divides this number completely. One is first number is 1, second is the same number 2. See, this number can be divided completely by 1 and the same number. Same number means this number, same number. So there are only two numbers. Okay, we will say factors. Factor means it is a number that will divide. See, there are only two factors that can divide these two completely. If you take any other number and try to divide 2, you cannot divide the 2 completely. If you take 3, 3 cannot divide 2 completely. Okay. So, this 2 can be divided only by two numbers. That means it has only two factors. So, that is why it is called prime. Composite means composite numbers will have more than two factors. Prime number will have only two factors. Okay. So now 2 is prime number, 4 is composite number. Okay. So I hope you got what is composite and prime. Now what is this statement saying? Every composite number. So composite number, I will take example, I will take 4. Okay. So composite number 4 is example. What is this saying? Every composite can be expressed or factorized as a product. Product means multiplication. So is equal to into product of primes. Primes means I said 2 is a prime number. See, 4 can be written as 2 into 2, right? 4 is equal to 2 into 2 because 2 into 2 means 2 2 is a 4 we'll get. Okay. So this is what telling this statement from here to here. So meaning of this three lines from here to here is this. So every composite number can be expressed or factorized as a product of primes. Product means multiplication. See, 2 is a prime number, 2 is a prime number. Multiplication. this is called product. Multiplication and product are same. So this is product of primes, right? This is product of primes. 2 is prime, 2 is prime, and this is equal to 4 composite number. So this composite number 4 can be written like this. Like this means 4 can be written as product of primes. Okay. So that's what this is saying. Every composite number can be expressed or factorized. So whatever I have written, right, multiplication with prime numbers. So this is called factorization. So that's why they have written factorized in the bracket. Now it is like 4 is factorized like this, 2 into 2. Okay. So every composite number can be expressed or factorized as product of primes. So this is the meaning. I have taken an example. So you understood here to here. Next what? And this factorization is unique. Okay. This is unique. Unique means there is only one way to write the factors. I will take different example, you will understand. For example, see 30. So 30 can be written as 2 into 3 into 5. Correct. 2 3 is a 6. 6 5 is a 30. Now they are telling factorization is unique. Unique, and one more sentence is there. Apart from the order in which the prime factors occur. That means, see, 2 into 3 into 5 can be written like this. 5 into 3 into 2, and this can be written like this also. 3 into 2 into 5. Okay. This can be written like this can be written like this. All are same, because if you multiply this, you will get 30 only. If you multiply this, you will get 30. So if you multiply this, you will get 30 only. What I did, I just changed the order. First 2, then 3, 5. Here first 2 I have written, but here first I have written 5, then 3, then 2. Here first I have written 3. So what I did, I just changed the order of the numbers, the prime numbers. So these are prime numbers, 2, 3, 5. Okay. So if you consider order, there are different ways. There are different ways to write the factors like this. This is one way, this is other way, this is third way. Okay, if you consider the order. If you don't consider the order, there is only one way to write the factors. So don't consider order means numbers will be same. Okay. See, you can write like this, like this, like this. You can change the order of the numbers, but you cannot change the numbers. 2, 3, 5 fixed. Okay, you cannot change the number. If you change any one number, this value changes. Okay, you can change order, the order of the numbers, and you can write like that. But here also 2, 3, 5. Even here also 2, 3, 5. Even here also 2, 3, 5. Prime numbers are same. Same means unique. Okay. So, if you don't consider the order, whatever the order, there is only one way to write the factors. That means using 2, 3, 5 only. You cannot use any other numbers. So that is called unique. Unique means there is only one way to write the factors. That is 2, 3, 5 for this 30. So apart from the order in which the prime factors occur. That means whatever the order of the numbers, but you can only use these three numbers, 2, 3, 5 only. You got it? So that is the meaning of this. So meaning of this. So this factorization is unique apart from the order in which the prime factors occurs. So from here to here, the meaning is this. You can change the order of numbers. You can write like this, but you cannot change the numbers 2, 3, 5. 2, 3, 5 are fixed, unique. There is no other way. So that is the meaning of unique. Unique means you can use only 2, 3, 5 only. You cannot use other numbers. But apart from the order, that means order can be different, but you can use only 2, 3, 5 only. You got it right? So that is the meaning of the meaning from here to here. Now I hope you understood the whole meaning of this sentence. So this paragraph. Okay. Yeah, that's all. So I will take another example. I will take, for example, I will take 16. So 16 can be written as 2 into 2 into 2. 2. Now another 2 is there. 2 2s are 4, 4 2s are 8, 8 2s are 16. See, here all are 2s only. You can change the order. If you change the order also, you will get same thing, 2 2 2 2 only. Why? Because there are no other any other numbers. There is only one number, 2 2 2 only. So if you change the order also, if you don't change also, same thing you will get. But unique means except 2 you cannot use any other number. Okay. For example, instead of 2 into 2, if you use 4, of course, 2 2s are 4, 4 4 is 16 only. But this is factorization. In factorization, there should be only prime number. So this 4 is not prime number. That is composite number. Okay, because it has more than two factors. In the beginning only I showed you. So in this multiplication of numbers, only primes should be there. So if you write product of primes only, prime numbers only, then you have to use 2 into 2. 2 into 2 only. You cannot use any other number. If you use 3, this value changes. If you use 4, this value won't change, but 4 is composite number. We have to use prime only. Okay? So that time you can have only 2 2 2 only 4 2s only. You cannot rewrite this using any other number. There is only one way to write. Okay? So that is using 2 only. So that is the meaning of unique. Okay? So this will be asked for 1 mark actually. In previous exam, I think in 2026 board exam, 2026 or 25, they asked this for 1 mark. State the fundamental theorem of arithmetic. Okay. So why I explained this using different examples? It will be easy to remember these statements if you understand with examples. So that's why instead of just writing the statement, I have given you the examples and I explained. Okay. Hey, thank you. Subscribe.